Okay, let's see if we know how to do this. So when you see the fundamental theorem of calculus, we know that we need to do, you integrate it and you do f of b minus f of a. This is like your upper bound and your lower bound, okay? So, what? Thank you. There we go. It's always frozen. Okay, let me make sure my video is okay. All right, so we're doing the integral of x cubed plus 3dx from -1 to 1. So we integrate and we say x to the 4th over 4 plus 3x. Do you agree or disagree?
Agree.
Okay. Do I need plus c?
No.
No, because all of this now gets evaluated with that little line from -1 to 1. And then we do f of 1 minus f of -1. So we get this goes in first, and then this goes in second. So 1 to the 4th is just 1, so 1/4, plus 3 times 1 is 3, minus parentheses, right? What's -1 to the 4th?
+1.
+1 still, so 1/4, and then minus 3, right? 3 times -1?
Yeah.
Okay. So then I would actually just distribute to this in my head a little more. 1/4 plus 3 minus 1/4 plus 3. What's my answer?
0.
Boop, boop. Well,
6.
6. Yep. Okay. So again, what does an
6.
integral represent? An integral?
Area underneath. Area.
The area under the curve, right? So so it's like the area from here to here. Also bounded by the x-axis, okay? Right. I don't know if that's what that graph looks like, but I'm just giving an example. I'm just drew an x cubed graph. Okay, so today we are going to use the same properties we learned about yesterday, but we're going to evaluate them graphically. So we have gallant curly cues and majestic vision. Okay, turn to lesson 2 in your note packet. Lesson 2. Okay, so I am giving you one graph, and we're just going to do like A through J based on this graph, okay? All right.
0 to 2.
Okay, so I have this graph, and you're going to see, like, now we're going to kind of analyze the area under curve. If we can use geometry, we use geometry, right? So we're going to kind of interpret this integral using geometry. So I want the area of this graph, which consists of line segments and a semicircle. Evaluate each definite integral by using geometric formulas and properties of integrals. So from 0 to 2, right? How do you suppose I would find the area of this little section?
Figure out the whole thing, split it in half.
So how do I figure out the whole thing as semicircle?
Go from -2 to 2.
Okay. But what is the area? Yes.
Find the radius of circle.
Into a quarter, right? This is a quarter circle. Would you agree? So if I know the area of a circle is pi r squared, you guys know that? Pi r squared. So what would 1/4 of that be? Just pi r squared over 4. Does that make sense? Sure it does.
This is 2.
Yeah. Yeah. Oh, yeah. Go ahead. Sorry about that. Need somebody to help walk you? Can you see?
No.
Okay. All right. So then, hey, what's my radius? R is 2. right? That's my length. So I'm going to plug it in. Area is pi times 2 squared over 4. It's going to be 4 pi over 4 is pi. However, I am forgetting one very important thing. Does it make sense that I call this pi? Why?
Because it's not.
Where is it located? Below
Graph.
the x-axis. So it is going to be negative, right? So what you want to do, if you know it's going to be below your axis, you're going to say, hey, I'm going to pop a negative in here, and that's going to be negative pi, okay? So if it is below the x-axis, you know it's going to be negative, okay? All right. Letter B, from 2 to 6. All right, so we want this space here, right? What formula am I going to be using from that? Area is and again, we're reminding ourselves, we know integral means area from 2 to 6. What shape is this?
Right.
Triangle. Triangle. So what's the area of a triangle? 1/2 BH. Okay. So you should know the area of a circle, area of a triangle. Okay. What? That's outrageous. We're in calculus. We have to know that. Area of a triangle. Okay. Hey, what's my base? The length of this is 1, 2, 3, 4. Sir, why did I write 5? 4. Okay. So 1/2 times 4 times the height is 2. Yeah. Okay. So 1/2, the 2's cancel, you get 4. Okay. And check it. It's positive, right? It's above the axis. We're good. Okay. Let's do another one. Letter C. -4 to 2. Do you guys want to give it a shot? Or do you want me to go over it right away? Any preference? So negative this distance all the way to 2. Now, here's the thing. I already know this piece, right? So what can I conclude about this part? It is, yeah. So I knew the area here is negative pi. And the area here is also going to be negative pi. I don't really need to do a calculation for that. Okay. They told me it was a semicircle. Okay. And then the only calculation I really need to do then is the little triangle. So go ahead and do that. The area. I also, a lot of times when I find the area of a piece of a graph, I will write it. So I'm going to write on here the areas for, because I'll give you kind of multiple tasks to do with the same graph, and kind of knowing what each area sector is helpful. Okay, tell me what you get for the area of this triangle. -1/2, let's see. 1/2 times the base is 2. The height is 1 times a negative. Going to be -1, right? Does that make sense? Okay. So yeah, we pop a negative in front because it is below the axis. So it's going to be negative. Okay. So this is going to be -1. So my area from -4 to 2 is going to be -1 plus negative pi plus negative pi. I mean, you could have just done plus minus 2 pi, you know. So, but I'm just showing you it's a combination of that. Plus anything else? No, that's it. So my final answer here, -1 minus 2 pi. Yeah. Okay. That's it. Okay. How about the area integral of f of x dx from -4 to 6? And the only reason why I can't do the fundamental theorem of calculus here because I don't know what the function is. I just have its drawing. So I want -4 to 6. So I'm looking for the whole shebang. Yep. Which is why, do you see why I kind of write my summary of what my area of each section is? Because of that. So this is gonna be easy. Yeah. So it's going to be -1 minus 2 pi, right? That's to 2 plus 4. Does that make sense? And then my final answer there, 4 minus 1 is 3. Yeah, so 3 minus 2 pi. Is that good? Questions for me? No good? Okay. Okay, let's continue this. Let's do something interesting. I wonder if you know what happens to a graph when I want the integral of the absolute value of f of x dx. Now, we won't be dealing with absolute value a ton in this class for integration, but I do want you to know the general idea of what absolute value, if I say the absolute value of this function, what does that do to my drawing?
Makes everything. Everything is negative gets flipped.
Yeah, so every negative y value becomes positive. So watch. Wouldn't this line come up? Whoops, that was really bad. Wouldn't this line kind of come up like this, right? And this semicircle would look like this. It started off really nice. Look at that left side of that semicircle. That is some good. That is beautiful. But my right side is like, oh wait, here we go. There we go. There it is. Right? And so then everything else is positive. So therefore, if I want this, again, -4 to 6 is the entire length area. How is that going to change my area? It's going to be
5 plus 2 pi.
yeah. So you're going to say, okay, well, it's going to be that -1 was because it was below the axis, so it's going to be 1 plus a pi, so plus 2 pi plus 4, so it's 5 plus 2 pi is my area. That make sense? Okay. All right. Now let's talk about letter F, because here you're going to have to use some geometry skills and calculus skills, okay? So I'm saying if I take f of x and add 2, what is the integral of that from -4 to 6? So now I'm just looking at, I want this stroke eraser here. Okay, I'm looking at -4 to 6, it's that whole line, but I'm adding 2. So what I do is this is where I use my properties of integrals, right? The integral of from -4 to 6 of f of x, f of x dx, plus the integral from -4 to 6 of 2 dx. Yes? You good there? Then I know, I already figured this out, didn't I? The integral from -4 to 6. What was that? Was that in letter D? Yeah. 3 minus 2 pi. Yes? So I'm going to take, this was letter C. We found this in letter C. So that is 3 I'm not going to find it again because I know it. And then plus, can I find the integral of 2 from this graph? No. So I just integrate it, right? I can integrate 2. What's the integral of 2? 2x from -4 to 6. And that part is what I need to use the fundamental theorem of calculus on. So f of b minus f of a. So I do, oh my goodness. So this is going to be 3 minus 2 pi plus 2, you plug in the 6 first, f of 6 minus f of -4, f of b minus f of a. So 12 minus -8, yeah? So this is going to be 3 minus 2 pi plus 12 plus 8 is 23, right? 23 minus 2 pi. that right? Did I make a mistake? What?
By the 12.
So the 3 is the 3 minus 2 pi. So 12 and 8 is 20, right? Plus the 3,
At 2.
because it's minus a negative 8.
The minus. First one.
So I'm plugging in a negative 4. So it's 2 times negative 4 makes the negative 8. F of B minus F of A is your fundamental theorem of calculus. Okay? Yes. Any other questions? Yes.
I don't, how come you don't have the rest of the 3 minus 2 pi? Is it because you only have the 3 minus 2 pi, and then you keep that the same,
So
and then you just switch?
3 minus 2 pi was from negative 4 to 6. We found that out in letter C. Okay.
It's like with the.
Whoa, did you see that? That stayed on my screen. That highlight? What? How do I? That's weird. Hold on. Can I get rid of that? It won't let me erase it. Oh, that is weird. It's like I highlighted my. Anyway.
The plus 2x part, that's the only time that you plug in the 2 numbers for the x, you leave the rest, so you don't rewrite.
Right. If this is not something I can get from my graph, then I can integrate it. The reason I can't integrate the first part over here is because I don't know what f of x is. I'm not given the function. I'm just given the picture. So I use geometry for that part.
But you know what the 2dx.
But I can integrate too. So if there's something I can integrate, I just integrate it and use the fundamental theorem of calculus. Otherwise, I use geometry. Okay. All right. How about, this is so annoying. Why is it doing that? Sorry guys about that weird highlight. Okay. What about these? Okay. Do you remember, we're going to hit on this one a little bit. The integral from 2 to negative 2 of f of x dx. Now, you don't ever want to integrate on a graph from a higher bound to a lower bound because it changes your negative sign. So here's what you do. Switch the bounds. Do you remember the property for that? The property is the integral of a to b. Like, I'm going to make sure I write this out. So yeah, if I have the integral of b to a, like my b is always like the largest number of f of x dx. The rule says it's negative. I can switch my bounds from a to b, so my smaller one's on the bottom, and it's just the opposite of that area. Okay, so when you're in a graph, now I will say this, if you're in a graph, you always want to change those bounds. If you're integrating with the fundamental theorem of calculus, does it matter if you change those? It doesn't. And actually, I think it's easier not to, because your f of b minus f of a is going to take care of it. And if you factor out a negative, you're going to have another negative sign to worry about. Do you hear me there? So we only do it when we have to, and we do have to do it on the graph. So I'm going to write this as the opposite of the integral from negative 2 to 2 of f of x dx. I switch my bounds. You always want low to high, okay, when you're dealing with a graph. So from negative 2, let's see, negative 2 is here to 2. It's just going to be that semicircle. Do you guys know what the area there is? We would say. It is 2 pi because, well, we have, remember this area was negative pi, and this one was negative pi. So we would say it becomes negative of, whoa, my pen went weird, negative of negative 2 pi, right? Do you agree with that? Any questions there?
No.
And so it becomes positive 2 pi. Does that make sense? You see how when you switch the bounds, it makes it a different sign?
Like
Okay.
the numbers when you flip them.
Yeah. Yeah. Okay. Why don't you try, well, do you want to see another one, or do you want to try this one? You want to try it? Give it a shot. Try letter H. You always want lowest to highest when you're doing a graph. Again, it doesn't super matter when you're doing it analytically, because the calculus, fundamental theorem of calculus takes care of it. I'm gonna start writing the steps. Sound good?
Oh, I got it.
Okay. Oh, whoops, that was wrong. Okay, do you agree with what I have on the board right now for H? The opposite of -1 would be plus a negative pi, so I just wrote -1 minus pi, right? -1 plus a negative pi, so -1 minus pi. Right, the area of that triangle, yeah. So then it would be distribute the -1 plus pi. How are we feeling? Thumbs up, sideways, down? Okay, all right. For letter I, from 6 to 0. Oh, gotta switch it. Gotta switch those bounds, least to greatest. 0 to 6. But it's gonna be opposite with that negative outside. Go ahead and try to find that. The integral from 0 to 6. Okay, I got the opposite of negative pi plus 4, which is pi minus 4. Yeah? Okay. Do the last one. Go ahead and do J. I'm going to let that all be you. Do letter J. You'll have a choice how you want to proceed with this one because you'll have to do some geometry and the fundamental theorem of calculus. Here's what I would do first. I'd split it up. Not quite.
Not the total answer for
The number should be -17. I got no -17 plus 2 pi. So here's what I would do. This highlighted portion, you have to do with the graph. So you have to change the bounds, right? So I would say, well, that's going to be the opposite of the integral from -4 to 2 of the graph f of x dx. And I'm going to leave this part as it is because this is analytical, right? I can just do the integral of 3 is 3x from 2 to -4. And f of b minus f of a, which is f of -4 minus f of 2, that minus in that formula is going to take care of it. I don't need to worry about it, yeah? So again, you could do the opposite of -4 to 2 of 3dx if you want, but it's just going to be a little confusing. If you do it that way, you just gotta you'll have a lot of negative signs. So I don't love it, so I chose this way. What's integral from -4 to 2?
How come you don't flip that sentence?
Because it's analytical. If it's graphical, I always have to flip it because it's an
So-
opposite sign. If it's analytical, do you see that minus sign in f of b minus f of a? It takes care of it for me, and I don't have to worry about it. Okay. But you still could do it. You could compute it this way and you'll get the same thing. I can show you. I'll show you that it works out. It's just a little more confusing. So I'll come back to that. Okay, so we'd have from -4 to 2, we have, that's this here, -1 minus 2 pi. So the opposite of -1 minus 2 pi. Does that make sense? Okay, then plus, flip them in here, 3 times -4 minus 3 times 2, f of b minus f of a. So it's going to be distribute 1 plus 2 pi minus 12 minus 6. So that is -18 plus 1 is 2 pi minus 17. Okay. Now, if you did it over here, like I told you, you can solve it if you initially just did the opposite of the 3. So here's what it would look like if you'd have like your 1 plus 2 pi minus, and then you have to like use parentheses here, 3 times 2 minus 3 times -4. You'd have to have like a couple sets of parentheses if you did. So it'd be minus, 6 plus 12 minus 18. So you still get 2 pi minus 17. Okay. It's just a little bit more annoying with the negatives. Okay. All right. So that's it.